Dear followers, here we are going to discuss different types of pavement. Pavement is the upper part of roadway, airport, or parking area structure. It includes all the layers resting on the original ground. Thus, this system is a multi layer system that distributes the vehicular loads coming from the top surface over a large area of the ground. Here we can see the load distribution phenomenon. Load is coming from wheel load. Wheel is supporting the whole vehicle, and this load is transferred in the form of point load. Means actually it acts as a point load. So the wearing course or top layer of the road is facing more load because the contact area is very smaller as compared to other layers. Then load is distributed towards the base layer and then to sub base and finally to subgrade. This whole story is actually associated with the flexible pavement. In flexible pavement, the load acts on a smaller contact area and is distributed towards the subgrade. Here we have a simple comparison between flexible pavement and the rigid pavement. We can clearly see that load is distributed on a smaller contact area in the case of flexible pavement, and load is distributed or transferred to a large contact area in the case of rigid pavement. The chances for settlement of the subgrade in the case of rigid pavement is less as compared to the flexible pavement. These two are basically the two major parts of pavements in road. So here we have the types of pavement in which flexible pavement is made of asphalt concrete and rigid pavement which is made of concrete or cement concrete pavements. We have a third part or third type as well, which is known as composite pavement, which is made from the combination of flexible pavement and rigid pavement. Especially in the case of bridges, you can see a deck slab as a rigid pavement, and then an overlay of flexible pavement is provided. Here we are going to discuss the flexible pavement and rigid pavement and their main difference. The main difference is that flexible pavement is a hot mix asphalt pavement in which the bitumen is used as a binder. Somewhere tar is also used as a binder. The basic difference between tar and bitumen is that bitumen is made from the fractional distillation of crude oil, while the tar is made from the fractional distillation of coal. So when tar or bitumen is used as a binder, then the type of pavement is known as flexible. And when the Portland cement is used as a binder, then the type of road is known as rigid pavement. Uh, when the rigid pavement and flexible pavements are used both at a time, especially in the case of airports, where rigid pavement is provided, and then for flexibility an overlay of flexible pavement is also provided. The same condition we can see in the case of bridges as well. On the other hand, the rigid pavements are the pavements in which cement is or ordinary Portland cement is used as a binder. This type of road have higher life as compared to the flexible pavements, but of course the initial cost is also much higher as compared to the flexible pavement. We can clearly differentiate flexible pavement and rigid pavement. In the case of rigid pavement, you can clearly see the longitudinal and transverse joints. Actually, the rigid pavements are laid in the form of slabs. So transverse joints and longitudinal joints are provided. The design of flexible pavement is the basically layer thickness selection. Here we can see that if you are using thumb rules, then 2 to 4 inches are used for the wearing course and 4 to 10 as a base layer, and while the thickness of sub base is selected between 4 to 10 inches. But for proper design, you have to conduct a traffic study from which you will get the excel load in the form of easels, and then you have to conduct the soil tests from where you will get the cbr value. From when you convert this cbr value into the modulus of resilience mr value, then you will have a structural number. From this structural number, you can calculate the layer thickness for asphalt layer, for base or asphaltic base, or sub base. So these are the common layer thicknesses provided: asphalt layer, aggregate base, and sub base. If traffic load is more or soil bearing capacity is less, then somewhere asphaltic base layer is also provided. The basic phenomena of load distribution is that in the case of flexible pavement, the load is acting just like a point load. Here we can see at wearing course the load is acting with a strength of 150 psi, and it is distributed towards the underneath layers. Here you can notice that the contact area is increasing when the load is distributing towards downward. This increase in the contact area is an indicator for us that the wearing course or asphalt wearing course will face the more load and is more critical as compared to the others. That is why it is also more powerful, more having more bearing capacity as compared to the base layer and sub base layer, due to which it can successfully face the point load. And finally, the second one layer facing more load is base layer, and then sub base. Finally, you have to transfer this load to subgrade. If the bearing capacity of subgrade is less, then it will be unable to even bear this 3 psi as well. Thus, for the construction purpose, the first step is to prepare the subgrade. Also, we call it as clearing and grabbing. Means you have to clear the ground from bushes, etc. If the subgrade is not properly prepared or not compacted, in practical terms we call it as NGC, natural ground compaction. So if NGC is not properly done, then you will have transverse cracks, and also you have to face the rutting in your roads. Rutting is the settlement of road in the direction of traffic, or where the tires of traffic or vehicles are running, then settlement occur. This is known as rut or rutting. The phenomena is known as rutting. The main cause of rutting is also the settlement of subgrade. The second important thing is to select a proper plan for the aggregate base layer. You have three types of blends. One is densely graded, one is open graded, in which the gap between the particles is more. The third one is gap graded. Gap is also when you do not select a proper blend, then you will have a more gap between the particles, or you may have larger particles. So, uh, best thing is that you have to select a balance graded blend. Dense graded blends are also not good because they don't have space for the future compaction. Um, Also, though the open graded are start start the compaction, due to which you will have uh, different kinds of distresses in the roots. And the most important step is the selection of asphalt content. The asphalt content is selected by making a job mix formula. Especially the Marshall stability test is used to select a proper blend, and also um, an asphalt content that can bear the or that can face the maximum load, and having standard air voids with minimum flow. Is a huge process of asphalt selection or Marshall stability test. In the next lecture or upcoming lectures, I will discuss it in details. Thank you for watching this lecture. We will try to share our practical knowledge with you.